Lessons.
Hello and good day, geometry. We are starting with algebra, PO61. It's a trip through radicals, and I'm going to start by simplifying them. And this is because in geometry, especially when we get to right triangles, you are going to have a lot of answers that are in radical form, and just like a fraction, okay, we want to keep them. You know, whenever you convert something to a decimal, there's always that rounding piece, so you lose some of the accuracy. We're going to be dealing with a lot of non-perfect squares, which if you write them as decimals, you have to round. Because remember, non-perfect squares are irrational numbers, they're decimals that go on forever. So the trick to that is going to be to simplify radical expressions, similar to how you would simplify fractions. Your experience with radicals in the past, okay, back in pre-algebra, in CO12, we evaluated them, which simply means I gave you a perfect square, you told me what that value was. What is the value of 36? Or the root of 36? It's 6. Because the definition of a root is what times itself, right, equals, in this case, 36. What times itself equals 121? 11. So the root of 121 would be 11, right? That was your first experience with the roots thing, okay? Then in algebra CO2, we went to estimating them. Where I was not testing, can you just put root of 19 into a calculator? This is where you had to kind of visualize where it appeared on a number line and approximate what decimal it would be. So the root of 19, who remembers the strat for this? Hugo?
You would do like the square lower than it,
Right.
higher than it.
The root of 16, we said, would be 4. The next highest perfect square, the root of 25, that would be 5. And so we knew that the root of 19 was somewhere between 4 and 5. And how do we kind of narrow that down a little bit?
Whichever is closer to.
Exactly. Root 19 being closer to root 16, that means that its value is closer to 4, and from there you would estimate 4.2, 4.3, 4.4, 4.1, whatever.
4.5.
4.5 would have been marked wrong, because this is not halfway between 16 and 25. Okay?
What about 4.449?
Sure, whatever, okay? So what would an approximation, a close approximation of the root of 200 be?
10. No.
I got this.
Hold on, I think it's this one.
14.
Nope, that's it. Okay?
What's 19?
An approximation of the root of 200. Yeah, James.
13 and 14.
Okay, it's between 13 and 14. Is he correct on that?
Yeah.
Isn't 13 160?
No.
13 is 169. What's 14 squared?
128.
196.
196.
Oh!
Okay. So it's between 14 and 15. Root, or 14 squared would be 196. 15 is the root of 225. So what would your
14.2.
14.2, 14.1, 14.3, somewhere in there?
It's 14.
Okay.
Oh.
Lastly, root of 44. What would you come up with for this? Just give me don't walk me through how you found it, just give me the decimal answer. What you would approximate that to be, root of 44.
22.
Sorry?
4 and 11.
No. A root is not being divided by 2. A root means what times itself equals, in this case.
6.7.
6.7, okay. It's between 36 and 49. It's closer to 49, so it's closer to 7. You know it's 6.7, 6.8, 6.6, it's somewhere in there.
6.9.
When you count 6.4?
Shh, no.
Why?
Because that would mean it's closer to 36 than it is to 49, which it's not.
Is 6.9 more?
Sure. That's the second time today you brought that up. Evan.
And it is free.
Yep. Teacher's talk. Go ahead.
I forgot.
Oh, okay. So the drawback to that is that it's an estimation, right? We are rounding here. And as you get further, especially into Algebra 2, you're going to be expected to keep exact values of things because you're going to be using those values for something else. And the more you round answers and use those round answers and continue to round, then you just lose all that accuracy. So we are going to focus PO61 on simplifying each radical.
Yay.
Okay? Notice these are all non-perfect squares. That therefore we cannot evaluate them. Right? James? Shh. Using calculator, is merely going to give you a rounded decimal answer. That's what we just did up above there. We don't want that. We want to simplify them. Keep those exact values. So what we're going to do is we're going to start with looking at 45 here. The strat for this is we want 2 factors of 45. Because just like we can write 45, just the number by itself, as not 5 times 15, that's 75. 3 times 15, okay? We can write the root of 45 as the root of 3, and don't write this down yet, times the root of 15. Right? It means the same thing. We can break up a root like that, the product of 2 roots of its factors. But we don't want to use 3 and 15 for this because there's nothing we can do with the root of 3 or the root of 15. What's another factor pair of 45?
9 and 5.
9 and 5. If we rewrite the root of 45 as the root of 9 times the root of 5, what have we just given ourselves here? What do we know about the root of 9?
It's equals 3.
It's a perfect square, right? Embedded in 45 is a perfect square factor. That's what we're after. Because rewriting root 45 as root 9 times root 5 and having that perfect square, we can rewrite this to be 3. Because the root of 9 equals 3. They're equivalent values. And the fact that root 5 is not a perfect square, that's okay. We leave that just as root 5, and our final simplified answer is 3 times the root of 5.
Oh, it's that
Okay?
easy?
Is that more complicated?
It does get more complicated because we'll introduce variables, we'll introduce fractions, things like that. But this is the basic-ativity of it. Okay. If you've got a calculator, take out your calculator. Chance said he would just use his to simplify this. It doesn't do it for you. You can. However, if you type the root of 45 into your calculator. The root of 45, if you're unsure how to take a root, here's your giant calculator. I'll try to. Here's your giant calculator here. Here's your display.
Bazinga.
Oh yeah, you should want to use your eyes.
Okay. In order to get the root symbol, you need to know where your second function is, which is the top left button, usually a different color from most of the other ones. And then around the 7 key is the x squared button. You don't want x squared, but printed on the calculator above this is the root symbol. This is like your shift key, like on a computer. If you want to get the dollar sign, you have to do shift 4 or a capital, shift, then whatever letter you want. If you want this root symbol, you have to push this shift key first and then the x squared button. Okay? The difference is this is not an actual button. It means you have to shift first. So you do that, and in your display, you'll get the root of 45. Or you'll get the root of, then a parenthesis, you type in 45, close your parentheses, and who wants to read the nasty decimal that you can get from that? Aiden, go ahead.
6.708203932.
203 what?
932.
932, okay? Now, if you clear that, or just keep it there, and then you take 3 times the root of 5, guess what?
What?
You get 6.708203932. Okay? When you simplify something, you don't lose any of the value. So, Chance, you want to use a calculator to help you? You can use a calculator to check your answer. If you start with the original term, and then you simplify it, and you find the value of your simplified term, these will match. If they don't match, you did something wrong. So that's how you can use a calculator to check it. Yeah?
So this would not help guess and check?
Guess and check, it would be difficult to do. Evan?
Why do you have to put the parentheses at the end?
So, some of you ran into this last year with when you plug an x value into a quadratic equation, like you found the x value of the vertex and you plug it in to find the y value. Some of you struggle with this with the quadratic formula. If you don't close parentheses, it can mess up the order of operations. So it's just better to always get in the habit of closing them. versus do I need to here, do I not need to here, maybe I will, maybe I won't. If you always close them, then there's less chance of mistakes, okay? Okay, questions on that? So far so good, James.
So we're just looking for one that has a root, a number that has a root, and then the other one doesn't have to have a root.
Your final answer will look like this. You'll have a coefficient without a root, and then some value inside a root. And the reason why this is out of a root is because you found that perfect square factor that you could simplify. And then this one is a non-perfect square that you can't do anything with. Yeah?
Is there a number that doesn't have a factor like that?
Yes, and like if you were asked to simplify the root of 15, right? Your only options are 3 and 5, nothing you can do. So that would already be in the simplest form then, okay? The root of 20, what is a factor pair that we can use for this? 4 and 5 is an option, 2 and 10 is an option. Which is the option to use? 4 and 5. Because that 4 is a perfect square. So if you're sitting there thinking, ooh, I should know my perfect squares for this. Yes, you should. Okay? Yes, you should. And what does this simplify to be? 2, right? The root of 4 is 2. That's why we want this perfect square, because we can simplify it. 2 times the root of 5. And that would be your final answer. You wouldn't need to write the multiplication symbol in there. It's understood. You have a number followed by a root that you are multiplying. Root of 700.
100 times 7.
100 times 7?
Oh, yeah.
No.
Yeah.
Yes.
Yeah.
I use 25 and 28.
We'll come back to that. Root 100 times root 7. I'm going to write it a little bit over to the left because I do want to bring up Chance's option 2. So root 100 times the root of 7. What does that simplify to be? 10 times the root of 7. Root of 100 is 10. And then the root 7 we can't do anything with. Chance said he used something else. Chance, what did you use?
Square root of 25 times the square root of 28.
Okay. Now, should this work?
Yes.
Yeah, because 25 is a perfect square, right? And if we simplify root of 25, we get 5. But this looks different than 10 times the root of 7.
Yeah.
They equal the same place.
They do equal the same, though. 5 root 28 is not in simplest form. Why not?
Because it can get divided.
Because why?
It can get divided.
What do you mean?
What?
Hugo?
Because 28 has factors.
Because 28 can be simplified further, right? What's a square root? What's a first square factor of 28?
7.
7 and 4. So we can rewrite this to be 5 times the root of 4 times the root of 7.
Well, then that's simplify again.
And then you have to, yeah, you have to simplify again.
What does the root of 4 become?
2.
2. So now we have 5 times 2 times the root of 7,
Equals 10.
which equals 10. 5 times 2, root 7. Okay? So this would be like if I gave you the fraction 10/20ths and asked you to simplify it, and you went down to 5/10. Did you simplify it? Yes. Is it in simplest form?
Yes.
No. You can go further down to 1/2. So when you've got a situation like this where there's more than one perfect square factor, you've got to be careful, because if you don't pick the largest perfect square, which 100 is the largest perfect square of 700, you could end up in a situation like this where you have to recognize, oh, I can go further. I can simplify that root of 28 further. And eventually you will get to the same answer. Okay? It just takes an extra step. So always be thinking about what is the largest perfect square that I can take out of my original number. Okay? Root 72. Who has an option for us?
9, 6.
9 and 6?
8.
9 and 8? Okay. Root 9 times root 8. 9 times 8 is 72. Root 9 is a perfect square. What does it simplify down to be?
3.
3.
But 8 can be simplified.
Oh, yeah. Oops.
Whoopsie. What?
Oh, 12.
There is
12.
one. I think it's the second one in. There it is. Yeah. What was our whoopsie-doo here?
A can get divided.
We didn't pick the largest perfect square. Okay, what is the largest perfect square of 72?
12,
Nope, not a perfect square.
24.
9 and 8.
4 is less than 9, so no.
46.
12 and 6,
16,
12 and 6 are
16,
not
16.
perfect squares.
18.
16 does not go to 72.
46.
36.
That's not
I
6.
said 46.
36 times 2 is 72. The root of 36 times the root of 2 is the root of 72. 36 is the largest perfect square. So when we simplify this, root 36 becomes a 6. Then we have the times root 2, and that ends up being our final answer. 6 times root 2. For those who started with root 9 times root 8, we can still fix it, right? Because root 8 can be written as the root of 4 times the root of 2. And what's the root of 4?
2.
2. So we have 3 times 2 times the root of 2. And what's 3 times 2?
6.
6 root 2. Okay? 6 root 2. Yeah. Who would be? How are we doing so far? Who would you say we're still backing up? Y'all want to be here?
I wish I were.
I'm cooking.
Okay? Questions on these so far?
Can you do the bottom?
Okay. We've got about 10 minutes left. Your homework for tomorrow is going to just be this first page. So if you're comfortable with what we did up here, the rest of these are just like those, just different.
The bottom.
On James J. I need like a slow down
Same
button or
thing,
something,
but
like
just
a.
fraction.
What's this
Oh
one?
my god.
No, did not fit the situation.
Get the, oh my.
When you get down to the fractions, who remembers the trick of how to deal? And who remembers how to deal with a root of a fraction? What's the strat for this?
Divide.
No.
Multiply.
No, R comes first.
Wrote that.
Here's what you can do. The root of 27/16 is equal to the root of 27 over the root of 16. You can split that root into the numerator and the denominator separately. And the reason why we like this is because the root of 27 over the root of 16, what do we have now in our denominator?
Root of 27 over 4.
Spirit of Christmas, a perfect square. We can evaluate that to be 4. The root of 16 equals 4.
So we just have
That's
that.
it.
And if you had success in the top part, what do we do with this root 27?
We just continue.
How, Tatum?
5 by 4. 9 and 3.
9 and 3. Okay? 9 and 3. We have the root of 9 times the root of 3. There's our perfect square, that root 9 there.
Give me a second. Okay, now 3.
And we want that root 9 because what does it equal?
3.
3. So the root of 27 becomes 3 root 3, and that ends up being the numerator of this fraction. 3 root 3 divided by 4. And again, if you were to take this root of 27/16 and whatever nasty decimal you get in your calculator, if you take 3 root 3 divided by 4, it's the same exact nasty decimal.
Wow.
Okay? You've done it correctly. Tegan. Just this first page, yes. Don't look at what's on the next page, just for your own sanity. Why
Oh my
not?
goodness.
Why did you look?
No.
Evan.
Mr. Jones.
So, one, like, for each of these fraction equations, the denominator can get put to a whole number.
Yes, I'm being kind. For these first 4 fractions, you'll notice that all the denominators are perfect squares. That is strictly in the spirit of Christmas.
It's not even.
If you don't look ahead, but it's not always going to be that way.
Oh my god.
Enjoy page 1 of PO61. James Mishka.
Isn't this technically due on Thursday? Since we're doing the math packet?
Good point. Yes, it's technically due on Thursday because we're doing the math packet tomorrow. Job well
My
done.
guy's looking at me. James, you're so smart.
Cause you're, let's see, hold on, let's see, what's this one? Does it fit the situation?
Let's test those buttons.
What's this one? I did that one already. What's this one? I hope that's not it either.
The black button.
The black one's the air horn. That,
That hurts.
I know.
Jimmy, the yellow one, the yellow one.
This one?
Try the yellow one.
I know what that one is. That's the Simpsons, that one.
Oh, that doesn't fit.
That is not-
Oh, is that why it's yellow?
I think
Maybe.
No, I think the blue is brilliant.
Yes.
Oh, there it is.
Wait, which one's the method?
That's that one.
Look at.
That's the unpressable one.
Tatum,
Until
Tatum.
true math excellence is displayed.
Can you
Tatum
press
got
the
it.
brown one?
The brown one,
Wait, what's
this
y
one,
times
No,
five?
no, the last one.
the black one, that's the air horn, super loud.
Just do it.
Gosh.
Not that one.
What's the denied one?
Denied?
Yeah, we
That's,
heard that
that's
from
the
over
first
there.
one.
Yeah, we heard that.
Did you? No. Excellent. Anyway, so that was
What's
fun.
bottom left?
No, we didn't.
Your homework for tomorrow, finish the first page.
No, Thursday.
What's bottom left?
We have more time to go over at least one more if you want to. Is there any, Luca?
Yeah, borrow, okay.
Not right now.
The last one.
The last one? Okay.
No.
So the root of 147. Evan, Christopher?
Just grab mine.
The root of 147 over 64. Again, we can split this up into the root of 147 over the root of 64, and we rejoice in the kindness of Mr. Schultz because the root of 64 is equal to 8. You've got that perfect square. When the denominator is not a perfect square, it's a whole nother big marbles. But in this case, we're not quite there yet. So we're focused on the root of 147, okay? And who's got the perfect square factor for 147? Evan?
Never mind.
49.
And?
Something.
4.
Yeah,
I
okay?
skipped the button.
So root 49 times root 3, which that root 49 was what we wanted because that is a perfect square. That gives us 7 root 3. And so our numerator, 7 root 3, our denominator 8, and there's our simplified answer.
Wrong one.
Sir?
Boy, you did the same one above. You did 363 twice, and I just wanted to thank you for it.
Oh! You're welcome.
No, like it's
Oh, you did it
written
twice.
twice.
No, yeah, every year someone says that, and every year I freaking change it. So I will accept your gratitude with gratitude.
Do it for the sub, yes.
Change it?
Yeah.
Be so mean.
Do it, do it.
What should I change it to?
Hard questions.
No!
10,552.
Let's see.
You want me to know, Barry?
How about whoopsie-doo. There. So let's see. What's a perfect square factor we can put in here? Do I use 81 anywhere?
Bro really hit that.
Oh, do one.
What's 81 times 3?
Yeah, do it that.
243. We'll do 243. 81 times 3. Okay, hold on. I'm going to do my outro and then I can help you. Ready for this? Here we go. That's how you math.
Forget
No,
the like and
it's not.
subscribe.